Hello, class. Today we're going to be learning about wind. What is wind? Well, wind is horizontal air movement. So, why does air move horizontally? Because pressure can vary even at the same elevation. This pressure difference is generated by the unequal heating of Earth's surface. Air is constantly moving from areas of high pressure to areas of low pressure. So think of a balloon. When you pop it or open it, air will quickly rush out because it wants to move from that high concentration or that high pressure to a low pressure zone. Some other ways that we can look at air are when we talk about the Coriolis effect. So what is the Coriolis effect? Coriolis effect is when air curves, and in the northern hemisphere, the air is going to curve to the right, whereas in the southern hemisphere, air will curve to the left. And this is caused by the Earth's rotation, because Earth rotates slower at the poles than it does towards the equator. So the air near the equator is deflected to the right or the left, depending on which hemisphere you're in. And we can see this when we talk about big storms, because when we have hurricanes, for instance, um, we'll see in the northern hemisphere that they move counterclockwise because the center of the storm is a low pressure zone and all the air is being deflected to the right around the storm. So this causes that rotation that we see in a counterclockwise movement, and this would be a clockwise movement if we were in the southern hemisphere. So with air, we also have something called front. A front is defined as a boundary between two air masses. The boundary zone can be wide or narrow depending on the type of front. Warm fronts are typically wide, between 10 and 100 kilometers, whereas cold fronts can be narrow, down to less than a kilometer in width. Examples: a cold air front occurs when cold air advances and displaces or lifts upward the warmer air ahead of it. And so if we look at fronts on a map, we can see that a cold front is a blue line with jagged blue triangles coming out of it on one side. A warm front is a red line with red half circles coming out of it on one side. A stationary front is where you alternate between the blue triangles and the red half circles, and they'll be on opposite sides of the line. And an occluded front has both the triangles and red half circles, but on the same side of the line. So those are the symbols that you would see on a map if you were watching the news. A weather front is a boundary separating two air masses. So these types of fronts are, of course, the cold, warm, occluded, and stationary fronts that we just described. So how does the air that we see on Earth affect the climates that we see in different parts of the Earth? Well, areas where air masses form are called source regions, and we have a lot of different ones on Earth. There's Arctic and continental polar air masses and maritime polar air masses, and these are all defined by where the air is located. So air near the Arctic Circle would be an Arctic air mass, and then air over the water would be a maritime air mass. So Arctic air is typically bitter cold, and tropical air is typically warm. So you typically have warmer climates in those areas and colder climates towards the poles. This is mainly due to the sun's unequal heating of Earth's surface. So because the sun hits the equator more directly, the Earth is going to be warmer in that area, and therefore the air around it will be warmer. Whereas near the poles, the angle of the sun hitting the Earth isn't as direct, and so it is colder in those areas, and therefore the air over those areas is typically colder. So that's why we have the different climates that we do in the different parts of the Earth, because it's due to the unequal heating of the sun, which then in turn, when heat rises, causing causes the air to change temperature and causes the different types of air masses we see across our planet.